Dear students, welcome to readmedprep Academy channel. Today in Environmental Issues Part 4, we are going to talk about the solid waste management, in which we are going to talk about the radioactive waste, medical waste, e-waste, plastic waste. In addition, we are going to talk about the ECOSAN toilets. Introduction. Every day, tons of solid waste are disposed of at landfill sites. This waste comes from homes, offices, industries and various other agricultural related activities. These landfill sites produce foul smell if waste is not stored and treated properly. In the right side image, you can see the excess solid waste being dumped in the land. When hazardous waste like pesticides, batteries containing lead, cadmium, mercury or zinc, cleaning solvents, radioactive materials, e-waste and plastics are mixed up with paper and other scraps and burnt, they produce gases such as dioxins. These gases are toxic and carcinogenic. These pollute the surrounding air, groundwater and can seriously affect the health of the human, wildlife and our environment. Here you can see the dioxin, a toxic chemical compound capable of causing cancer. Industrial origins, a byproduct of burning rubbish. Iron steel production, chemical industry. Dioxin compounds can be highly poisonous even in small doses. They are absorbed by the earth and by plants. Animal feed contaminated by polluted raw materials and oils from machinery can lead to production of dioxins. Chickens ingest dioxins embedded in the soil or found in the feed, passed into the human system by the consumption of eggs and meat. Egg safety level 3 picograms to 1 gram of fat according to the Environmental Union regulations. What are the health effects of dioxin? Chloracne, disfiguring and painful form of acne, heart and circulation problems, liver damage, reduced reproductive capacity, suppresses the immune system, impairs the nervous system. Exposure to dioxins can cause cancer. What are the major sources of solid waste? Waste category and sources. Residential waste contains food waste, plastics, paper, glass, leather, cardboard, metals, yard waste, ashes, tires, batteries and old mattresses. Industrial waste, packaging waste, ashes, chemicals, cans, plastics and metal parts. Commercial waste, thin and thick plastics. Food waste, metals, paper, glass, wood, cardboard materials. Institutional waste, wood, paper, metals, cardboard materials, electronics. Construction and demolition waste, steel materials, concrete, wood plastics, rubber, copper wires, dirt and glass. Agricultural waste like fertilizers, spoiled food, pesticide containers and other agricultural wastes. Biomedical wastes, syringes, bandages, used gloves, catheters, urine bags, drugs, paper, plastics, food wastes, sanitary napkins and diapers, chemicals. E-waste, electronic items like used TVs, transistors, tape recorders, computer cabinets, motherboards, CDs, cassettes, mouse, wires, cords, switches and chargers. So solid waste management includes the activities and actions required to manage waste from its inception to its final disposal. This includes the collection, transport, treatment and disposal of waste together with monitoring and regulation of the waste management process. It is all about how solid waste can be changed and used as a valuable resource. Case study, the Corporation of Chennai looks after clearance and management of solid waste in Chennai. Every day, around 5,400 metric tons empty of garbage is collected from the city. Door-to-door collection of garbage is done in most zones apart from sweeping, collecting and storing the waste in the specified bins. In the image, you can see initially the collectors were given tricycles and they collect the waste from door to door. On the right side, you can see now the collectors are given three-wheelers which can separate the waste at source. At present, garbage generated in Chennai is dumped at two sites. Proposals are there for remediation of the existing landfill or scientific closure and to have integrated waste processing facilities with waste to energy plants as one of the components at the existing Kodungayur and Perungudi sites. You can see here what a dump. Kodungayur, which has an extent of about 200 acres. Number of years in use 30. Daily waste disposal 2100 to 2300 metric tons of waste. In Perungudi, which is around 200 acres, it has been existing since 25 years. The daily waste disposal is around 2200 to 2400 metric tons. What are the waste management practices? Source segregation, composting using aerobic or anaerobic organisms, vermicomposting, biogas generation and incineration. Now let us go on one by one. First, let us move on to the radioactive waste. What are the radioactive wastes? Radioactive wastes are generated during various operations of the nuclear power plant. Radioactive waste can be in gas, liquid or solid form, and its level of radioactivity can vary. The waste can remain radioactive for a few hours or several months or even hundreds of thousands of years. Depending upon the level and the nature of radioactivity, radioactive waste can be classified as exempt waste, low level waste, intermediate level waste and high level waste. Here in this image you can see the low level waste. The sources are hospitals, laboratories, industries and nuclear power stations. Example, papers, rags, tools, clothing, filters, etc. The radioactive level is low. The middle you can see the intermediate level waste. Example, resins, chemical sludge, reactor components, contaminated materials from reactor. They are solidified in concrete or bitumen for disposal. High level waste with the main source is being the nuclear power. Radioactive waste management, which involves the treatment, storage and disposal of liquid, airborne and solid effluents from the nuclear industry. The 3 Mile Island, Pennsylvania, United States, Chernobyl, Pripyat, Ukraine and Daiichi, Okuma, Japan, nuclear disasters the world has seen in the recent period. Here you can see the waste characterization like the physical, chemical and radiological, which results in the formation of the radioactive waste where pre-treatment is done and treatment is done. The waste from the pre-treatment and the treatment which is exempt does not require any regulation of processing. The nuclear material waste is used for recycling or for reuse. The unused waste is taken to the conditioning process and then disposal is done by isolation in engineered modules. Methods of disposal of radioactive waste are limit generation. Limiting the generation of waste is the first and the most important consideration in managing the radioactive waste. Dilute and disperse. For waste having low radioactivity, dilution and dispersion are adopted. Delay and decay. Delay and decay is frequently an important strategy because much of the radioactivity in nuclear reactors and accelerators is very short-lived. Concrete and confined process. Concentrating and containing is the objective of treatment activities for longer lived radioactivity. The waste is contained in corrosion resistant containers and transported to disposal sites. Leaching of heavy metals and radionuclides from these sites is a problem of growing concern. Control and management. 3 ways are employed to manage nuclear waste. Spent fuel pools. The spent fuel discharged from the reactors is temporarily stored in the reactor pool. The spent fuel rods are used in stored cooling ponds. They protect the surroundings from radiation and absorb the heat generated during radioactive decay. In the right side image you can see the spent fuel pools. Vitrification method. This prevents reaction or degradation of nuclear waste for extended periods of time and encased in dry cement caskets. Here you can see the high level waste in the storage tank is taken and rotating heated tube causes the liquid to be dried to form a powder, and this is mixed with granular glass material. The dried waste and the glass material are mixed in mixing cylinder. 25% waste and 75% glass is present in the mixture. And finally, high-level glass vitrified waste is placed in a stainless steel containers and they are disposed. Geological repositories. A deep geological repository is a nuclear waste repository excavated deep within a stable geologic environment. It is suited to provide a high level of long-term isolation and containment without future maintenance. In India, at Tarapur and Kalpakam, a wet storage facility of spent fuel is the main mode of storage. Here you can see the deep geological disposal method where the fuel pellet of uranium dioxide is packed in a cladding tube which is kept in a copper canister with ductile iron insert and the spent nuclear fuel is present inside. Around it, a betonite clay is made and it is placed in a crystalline bedrock. On the right side image in the last, you can see the 500 meters distance between the underground portion of the final repository to the surface portion of the final repository. Now let us move on to the medical waste. What is medical waste? A kind of waste that contains infectious material generated by hospitals, laboratories, medical research centers, pharmaceutical companies and veterinary clinics are called medical waste. Sources of biomedical waste. Major sources are hospitals, labs, research centers, animal research laboratories, blood banks, nursing homes, mortuaries and autopsy centers. Minor sources, clinics, dental clinics, home care, cosmetic clinics, paramedics, funeral services and institutions. Medical waste contain body fluids like blood, urine, body parts and other contaminants, culture dishes, glasswares, bandages, gloves, discarded needles, scalpels, swabs and tissues. Below in the image you can see the types of medical waste, the infectious waste in the form of IV fluids, discarded IV tubes, syringes and various other materials. Then the sharps waste which contains the scalpels and the needles. Pharmaceutical waste, expired tablets, tablet covers, tonics, etc. And the radioactive waste. In the last you can see the non-hazardous waste. Management of the biomedical waste. The safe and sustainable management of biomedical waste is the social and legal responsibility of the people working in healthcare centers. Waste disposal involved by incineration, chemical disinfection, autoclaving, encapsulation, microwave irradiation are methods of waste disposals. Final disposal includes landfill and burying as per norms inside the premises. Now waste segregation you can see here, left side non-infected waste like the cytotoxic drugs and chemical waste which are placed in a black plastic container which undergoes chemical treatment and is disposed of to the secured landfilling. Infected waste, you can see the solid waste, infected dressings, POP casts are placed in red plastic containers. They are autoclaved and deep burial is done. Anatomical waste like placenta and other pathological waste and body parts are placed in yellow plastic containers. They are deeply buried. Infected plastics, syringes, gloves and plastic waste are kept in blue plastic containers. They are recycled after disinfection with 1% chlorine solution or sometimes mutilated. The sharps like the needles and the cut glasses and the scalpels are placed in a white plastic container and they are sent to Sharpe pit. All these wastes initially are sent to the common treatment facility where they are segregated and disposed accordingly. Now let us move on to the e-waste. What is e-waste? Electronic waste or e-waste describes discarded electronic devices as well as any refuse created by the discarded electronic devices and components and substances involved in their manufacture or use. Here in this image you can see the electronic waste or e-waste is the fastest growing waste stream which contains microchips, ICs and so many other materials. Their disposal is a growing problem because electronic equipment frequently contains hazardous substances. A personal computer, for example, there may be lead, Pb, in the cathode ray tube, CRT, and soldering compound, mercury, Hg, in switches and housing, and cobalt, CO, in steel components, among other equally toxic substances. E-waste are basically PCB, polychlorinated biphenyl based, which are non-degradable. Here you can see the different types of e-waste: scanners and printers, keyboards, mouse and other electronic devices, cell phones and tablets, audios and video equipments, television, monitor, and laptops, personal electronic devices. In addition, there are very many to be accounted. Used electronics which are destined for reuse, resale, salvage, recycling or disposal are also considered e-waste. Unauthorized processing of e-waste in developing countries can lead to adverse human health effects and environmental pollution. So, recycling and disposal of e-waste may involve significant risk to the health of workers and communities in developed countries, and great care must be taken to avoid unsafe exposure in recycling operations and leaking of materials such as heavy metals from landfills and incinerator ashes. Effects of e-waste on the environment: it causes pollution of groundwater, acidification of soil, air pollution. E-waste accounts for 40% of the lead and 75% of the heavy metals found in landfills. What is the effect of e-waste on the health? It causes DNA damage, lung cancer, damage to heart, liver and spleen, chronic damage to the brain, and it also causes asthmatic bronchitis. How the e-waste disposal is done? First, the e-waste is taken to the e-waste recycling center. The e-waste from the consumer is first inspected, and it can be repaired and sent to the market for used items. After inspection, it can be disassembled and can be refurbished and be sent to the market as used item, or it can be recycled and sent to the producer, manufacturer or vendor. After disassembling, if it is of no use, it is disposed of the disposable site for unusable parts. Now let us move on to the plastic waste. What is the solutions and remedies to dispose the plastic waste? Plastics are low molecular weight organic polymers that are non-degradable in the natural environment. They are used in several items, including cars, bulletproof vests, toys, hospital equipments, carry bags and food containers. Packaging materials used in supermarkets, retail outlets, manufacturing industries, households, hotels, hospitals, restaurants and transport companies are major contributors to plastic waste generation. Plastic waste constitutes a major part of the municipal solid waste. Remedies: 4R. Refuse, reduce, reuse and recycle mantra is the best available remedy for the plastic waste pollution. Tamil Nadu state government successfully implemented the ban on single-use plastics from 1st January 2019. Most favored option: reduce, lowering the amount of waste produced. Reuse, using materials repeatedly. Recycle, using materials to make new products. Recovery, recovering the energy from the waste. And the least favored option is the landfill, the safe disposal of waste to the landfill. ECOSAN toilets. What are ECOSAN toilets? About 150 liters of wastewater at an average is generated by an Indian individual daily, and a large amount of it is generated from toilets. Ecological sanitation, ECOSAN, is a sustainable system for handling human excreta by using dry composting toilets. On the right side, you can see the ECOSAN toilets in the villages. ECOSAN toilets not only reduce the wastewater generation, but also generate the natural fertilizer from recycled human excreta, which forms an excellent substitute for chemical fertilizers. This method is based on the principle of recovery and recycling of nutrients from excreta to create a valuable supply for agriculture. ECOSAN toilets are being used in several parts of India and Sri Lanka. In the right side image, you can see the inside of the ECOSAN toilet, which has two basins. Using the ECOSAN toilet, lift the lid with the hand, squat on top of the hole. Dispose used tissue in the big hole. After use, pour ashes into the big hole only. Replace the lid after use. Wash your hands before leaving the toilet. What is the structure of the ECOSAN toilet? You can see it has an alternate pit squat hole temporarily sealed, alternate pit vent pipe hole, removable cover slab. It has a sludge safe for manual removal after 1 year. It has a vent pipe to release the gases high and a fly screen. So today in Environmental Issues Part 4, we discussed about the solid waste management, in which we talked about the radioactive waste, medical waste, e-waste and the plastic waste. And finally, we discussed about the ECOSAN toilets. So thank you. Kindly subscribe, like, share and comment to channel ReadMedPrep Academy. Kindly register for UG and PG NEET type MCQs in our website www.readmedprepacademy.com. Our Facebook ID is ReadMedPrep Academy. Our email is readmedprepacademy@gmail.com. Our Instagram is ReadMedPrep Academy. Kindly post your questions in the comment box. We will reply with appropriate answers. To join ReadMedPrep Academy, WhatsApp the number given below. So thank you very much.